Morning, Matt. Okay, here we go. Homework yesterday was on the three shapes, the parallelogram, the triangle, and the rhombus. Any questions on that homework before I call out the answers? Did you get everything?
Can you help me out on the area of rhombuses?
Say again?
Can you help me out on the area of rhombuses? I'm having trouble on that.
Right. Okay. So the one theorem that we got on a rhombus is, well, let's just draw a quick rhombus. Remember, that means that all four sides are exactly the same. So it's basically a square that's kind of tilted. That means this side is congruent to this side, congruent to this side, congruent to this side. So the formula that we got was that if you draw diagonals, the blue one, and we'll make the other one green, that if you take the blue length times the green length, and they call it D1 for the green one, and the blue one, they call it D2, D for diagonal. You take those two, you multiply them together, and you divide by 2, you get the area. So that's all it says. So you take the two diagonals, multiply them together, divided by 2. So let me find one that says rhombus. Question number 4. This is number 4.
So in other words, I was extremely overcomplicating it.
Probably.
Okay.
It says on number 4, you have a rhombus that has diagonals 4 and 6. And it says, what's the area? So it's just 4 times 6 divided by 2 would equal the area. So 12. All right. Now it can be a little more complicated too, depending upon how they gave it. So for instance, number 14, I think, would be the hardest rhombus one to calculate, because it says you have a side length of 6 and an angle of 120, and that would be the only one that I would think that would be slightly complicated. All right. Any other questions?
Nope.
Okay. So here we go. Question number, let's see, 1 through 15 all. 1 is 29.9 meters squared. Question number 2 is 6 units squared. Number 3 is 12 units squared. Number 4, we just did 12 units squared. Number 5 is 16 root 3 square feet. Number 6 is 48 square units. Number 7 is 40 square units. Number 8 is 44 square units. Number 9 is 84 square units. Number 10 is 66 square units. Number 11 is 16 square units. Number 12 is 9 root 3 square units. Number 13 is 30 root 2 square units. Number 14 is 18 root 3 square units. And number 15, the last one is, in fact, I believe Matt and I, we did this one in, no, it was my other class that I did it. Or maybe it was this one, I forget. 25 root 3 over 2 square units. I know I did it. It was either this class or the other geometry class. We did 15 in class. Must have been the honors one.
I'd say I think it was, because I don't remember us doing that.
Yeah. All right, make sure you get that turned in on Teams. A couple of you didn't turn in homework, so I gave you 0. So since there's only 1 grade in the grade book, now there will be 2. That immediately gives you an F for the quarter. Congratulations. Make sure you're turning in your homework. All right, here's your homework for tonight. We get 1, I believe it is. Yeah, just 1 formula, so not too bad. We got 3 yesterday. We got 2 the day before, and today we just get 1. All right, here we go. And that shape is a trapezoid. All right, recall for trapezoids, because we had this already in the previous chapter, that a trapezoid is a quadrilateral. That means it has 4 sides. And what makes it a trapezoid is that 2 of the sides are parallel to each other. So 2 of the sides on a trapezoid are parallel to each other. It is not always the top and the bottom. It can be the left and the right. But not all 4 sides will be parallel. So just 2 of the sides. And that is the definition of a trapezoid. So it's quadrilateral with 1 set of opposite sides that are parallel. Well, that's not news to us. We call those 2 parallel sides the bases. And it doesn't matter which one you call base 1, base 2, but it must be the 2 parallel sides. And what I mean by that is if you want to call the larger of the 2 parallel sides base 2 and the smaller base 1, go for it. If you want to call the larger base 1 and then the smaller base 2, go for it. All right. We have some other names though. So the bases are the 2 parallel sides. The perpendicular distance between the 2 bases, called the height. Okay, that makes sense. What I haven't told you or shown you before is that we actually have names for the other 2 sides. We actually do have names for the other 2 sides. And the other 2 sides are going to be called, oh, there's the definition of height. The other 2 sides are going to be called the legs of the trapezoid. So we had legs of a right triangle. We have legs of a trapezoid. So legs of a trapezoid will be the 2 sides that are not parallel. Occasionally, you'll see a question that talks about the legs. So refer back to this slide or in your notes when they talk about the legs. So it's the 2 non-parallel sides called the legs. The other 2 sides are called the bases. We okay to move on? Okay. All right, and I wanted to visually show you this, the different orientations of trapezoids. So if you want to make the smaller of the 2 parallel sides base 1 and the larger base 2, you can. If I turn it sideways, notice the 2 parallel sides are left and right this time. I don't call the bottom always one of the base. It's the 2 parallel sides that are called the bases. There are 2 special types of trapezoids. One of them is called a right trapezoid. That's the one there on the far right, pun intended. That's called a right trapezoid. Why? Because it has a right angle. Now, remember the 2 bases are parallel. So even though all books will always show 1 right angle, technically there are 2 right angles on a right trapezoid. Because remember, parallel sides cut by a transversal, right? Then the interior, the same side interior angles are supplementary. Therefore, it's also equal to 90 degrees. All right, I got to do a pause right here. Someone's sending me a message. I just need to read it real quick. Make sure it's nothing important. YES. Oh, I know why it's not working. Oh, I'll try to do too many things at once. All right, back to class. All right, so the point I was making here is that even though the book, the pictures will always indicate if it's a right trapezoid, 1 right angle, that there are actually 2 right angles. The second special type of trapezoid is called, it has 2 congruent legs. Matt, take a guess what we're going to call one that has 2 congruent legs.
An isosceles trapezoid.
You got it. All right, so what makes it special is that not the bases will never be congruent to each other. What makes it special is that the 2 legs are congruent. They're not parallel, but they are congruent. All right, so the first upper left and the middle one on the upper row there, those are just your classic trapezoid shapes. We do see right trapezoids and isosceles trapezoids a lot. You'll see them today in class. You'll see them in homework as well too. Okay. And then lastly, just to reiterate the point for a third time, when you name your bases, it doesn't matter which one. If you want to take the same one and flip it around and call the larger side base 2 and the smaller one base 1, perfectly fine. Either either one is fine, and it doesn't matter which one is base 1, base 2. All
Does
right.
a right trapezoid, does an equilateral trapezoid exist?
Equilateral trapezoid does not exist. No. All right, so these are kind of how you will see in dimensional form or indicated lengths and distances of the two bases. Oops, sorry. So the distance between D and C, we will call base 2. The distance between A and B, we will call base 1. Now remember, from the previous couple slides, doesn't matter which one of the two parallel sides is base 1 or base 2. But the distances, once you determine which one is base 1, is the entire distance. Okay? All right, so let's get right on to the formula. You should remember this from 7th and 8th grade, at least somewhat vaguely, that the formula for area of a trapezoid is 1/2 times the height times the two bases added up together. Now, never proven to you. I'm going to prove it to you right now. All right, this one actually is a pretty simple proof. All right, here's what we're going to do. We are going to cut our trapezoid, not necessarily in half, but we're going to make a diagonal. So I'm going to make that diagonal right there. Okay, so let's cut that sucker from D to B. So that's just a basic construction. All right, we made that, and clearly with that diagonal, we have made two different two triangles, I should say, not different. So I've made this triangle right here, and I've made, we'll make it in green, I've made this triangle right here. So that's ADB and DCB. Those are the two triangles. So those are the ones that I'm going to talk about. We know that the entire shape from postulate 19, the entire shape would be those two triangles added up together. All right. So those two triangles added up together. Now, I do want to point out, we're not going to prove that these two triangles are congruent. They don't even look congruent. There might be a specific case where they are congruent, but there's plenty of cases where they are not congruent. Clearly, if B are the bases, right, then the bases are not equal to each other. So you wouldn't get the same areas, okay? But what we can say is that for each triangle, remember the area of a triangle is 1/2 base times height. So that for the area of the triangle, you can see that this height, well, that's clearly marked, but the height for this triangle here on the right is not marked. Well, remember, the definition of height is the perpendicular distance between the vertex, B is the vertex, and the opposite side. And notice this will be one of those, remember when we did a scaling obtuse triangle, the height was off to the side. Well, that's the case here, but since B1 and B2 are parallel, then these two heights would be exactly the same. So the distance between B and the side of B2, right, or if I extend DC, that height would be exactly the same height as this other one right here. So I'm going to claim that the area for both of those triangles, ADB, right, would be 1/2 base 1 times the height. And then for the other triangle, I'll color it here in red here, for this triangle right here, well, that would be this height, and base 2 would be the base. And so that's what I'm saying right here. Here's your triangle, I'll call it on the right, and here's your triangle on the left. Okay, and take the areas of both of those, add them together, and you get the whole darn trapezoid. All right, well, here's the kicker. I'm going to erase everything. Here's the kicker. And the kicker is that, well, both of these triangles have a 1/2 in it, and they both have an H in it. And the H is exactly the same for both triangles. So what I'm going to do, oh, by the way, that's just substitution and the distance between the two parallel lines. That's what the height is. So what I'm going to do right now is I'm going to factor out of the right side of this equation. I'm going to factor out a 1/2 and a height. And so when I factor that out, well, then you're just left with base 1 plus base 2. And as I said, this one's a pretty easy one, QED. So the area of a trapezoid is 1/2 times the height times the sum of the two bases added together. So there, it's finally proven to you. That's also why we don't prove those things back in 7th grade, I believe, is when you first deal with trapezoids. We just basically say, trust me, this is the formula, and I'll prove it to you in high school. And we just did. So let's write this down. It's the only theorem of the day. And there's the formula. Now that's the formula that's in the book. Most people like a more calculator-friendly formula. So the more calculator-friendly formula is, because we don't want to spend the time typing in a half, as we do the height times, remember on a graphing calculator, you got to use those parentheses, base 1 plus base 2, close your parentheses, and then divide by 2. So typing that into a calculator, the graphing calculator, h, open parentheses, base 1 plus base 2, close the parentheses, divided by 2. These are both the same formulas. They're just, one is calculator friendly, one is less calculator friendly. Matt, do you remember doing this in 7th and 8th grade?
Yes,
Okay.
somewhat, not like extremely, but somewhat.
Right. Okay. So in 7th and 8th grade, here's your 7th and 8th grade example. They give you a trapezoid. They don't really hide any information. They just give you exactly the information that you need. You have your two bases. You have your height. It's just a plug and chug. So the two bases are 8 and 12, and the height is 7. You toss those numbers in. If you're doing this by hand, remember you'd have to do the parentheses first because of PEMDAS. 8 plus 12 is 20. 7 times 20 is 140. And 140 divided by 2 is 70 square units. So there's your 7th and 8th grade examples. Well, in high school, they make your life a bit more challenging and they hide some information. So here is an example of a high school area question involving trapezoids. Notice there is no picture. And somehow they want you to read this and figure out the area of a trapezoid. So let's read this. It says, find the area of an isosceles trapezoid. So immediately I can draw a trapezoid. And I know that on our trapezoid that these two sides, called the legs, are congruent to each other. So there's my isosceles trapezoid. It says as a base of 6 and 10. Well, the bases are the two parallel sides. So I got 6 and 10. One's big, one's small. Well, use some common sense. Make sure that you put the small to the small side and the big to the big side. And it says it has legs of 5. So let's see, legs of 5. Remember the definition of legs would be the two non-parallel sides. And if one is 5 and it's isosceles, the other is 5. So there's my setup. So clearly, Matt, we are missing. What are we missing?
The height.
We are missing the height. So if
Sorry,
I
my mic
draw
isn't
the
working.
height suspiciously, I will put it right here instead of in the middle. And I suspiciously put it there because, take a guess.
You're going to need to do something that requires us to put it there.
Yes. And the suspicion there is probably Pythagorean Theorem. All right. So if I drew another height on the other side, I drew it a bit more nicer here, but I wanted to do it by hand this time. The other height would go right here. And the key here is the fact that it's an isosceles trapezoid. So if the bottom is 10 and the top is 6, guess what these little pieces are down here?
Sorry, my brain.
If the top is 6 and the bottom is 10, do you see the two triangles I drew?
Yes.
What are those two little pieces that aren't labeled then?
I'm attempting to figure that out. My brain isn't working. Where's my
If the
calculator?
top is 6 and the bottom is 10, how much is left off?
4.
Okay, but there's two.
So each
triangles.
side is 2.
So it's 2, right? So this piece is 2 and this piece is 2. Now we just need to find the height. So I don't need, and there's an isosceles, so both triangles are the same. So all I need to do is figure out this height if this side is 5 and this side is 2. So I'm going to use, finish the sentence.
Pythagorean Theorem.
There we go. So using the Pythagorean theorem, let's see, that would be h squared plus 2 squared A squared plus b squared equals c squared. And most people would probably just skip a step and just start working on it. So let's see, that would give me h squared, keep talking, Matt, plus
See, h squared plus 4 plus 25.
equals 25. Keep
Oh,
going.
sorry, equals 25. Subtract 4 from both sides.
Keep going.
And then do the square root of 21.
Okay. Any perfect squares in
And
21?
cancel out the square and h.
Any square root
Um,
perfect squares in 21?
I don't think so,
I
unless
don't think
I
so either.
am brain dead, which I probably am.
Right. So now we can go right to the formula now. So area of a trapezoid is equal to, I'll do calculator friendly one, the height, which we just figured out was?
4.5.
No, leave it as the square root.
I just did that on a calculator.
I know, but leave it as the square root.
The square root of 21.
Square root of 21 times the two bases added together. Yes, it's probably a pain. Most people would probably write 16 instead of 6 plus 10, all divided by 2. So 6 plus 10 is 16. So I get 16 root 21 all over 2. So the final answer, Matt, is? Just reduce the fraction.
16 divided by 2.
Yeah. I'm going to stop your hand if you're grabbing a calculator.
I'm actually not grabbing a calculator.
Good.
I'm trying to do this in my head. Let's see, it's going to be 8 root 21.
Perfect. All right, good job. And then remember, it would be in units squared because we're doing area. There we go. Questions? Here it is, nice and pretty with a prettier writing than what we just did. But we still got the same answer. All right. Let's do some. Recall that we had a chapter a long time ago where we talked about the medians of a trapezoid. And the median of a trapezoid, remember, would be a line between the two parallel lines that make up the trapezoid that is parallel to SR and PQ. So MN is parallel to SR and PQ, and it goes to the middle of the two legs. In other words, it cuts each side up into congruent parts. And this is theorem 519. You probably don't remember this because it was too long ago, but you can open up your book of truth and look it up. And here's what 519 said. Well, it said that all three of those, SR, MN, and PQ, are parallel. And further, it said that MN is equal to the two parallel sides added together and divided by 2. So this is just as a reminder that this is what theorem 519 said. So we take SR, we add it to PQ, we divide it by 2, and that turns out to be the distance, MN. Okay, so basically, if you wanted to rewrite it, and this was the formula we wrote that the median is equal to base 1 plus base 2 divided by 2. That sounds awfully familiar, right? Does this sound familiar? This part right here?
Yeah, but isn't it like rhombus?
Well, no, I'm
Like,
saying, no, that was
mostly it's like,
D1 times D2.
but it's like,
but
it's almost exactly the same.
Some, but one's
Minus
multiplication, one's addition. But doesn't B1 plus B2 divided by 2 sound familiar? Hint, something you wrote down about 2 minutes ago?
Are you insinuating that I wrote it down?
Yes, that you were supposed to write down 2 minutes ago. Doesn't
I've heard it before.
It look like the formula for area of a trapezoid? I mean, it's not, but it's has some similar parts. We got to divide it by 2. We got a base 1 plus base 2. Yeah, it's got some commonality with that formula for area of a trapezoid, right? So if you notice, I'll circle it in red here. Well, or maybe I won't. I'll circle it in red here. that is the median of the trapezoid. So there actually ends up being, this is theorem, this is covered up, I can't read it. This is theorem 11-5, and this is what it says. If the area of the trapezoid is the height times base quantity base 1 plus base 2 divided by 2, and we just defined from the previous one, theorem 519, right, that the median is base 1 plus base 2 divided by 2, we can write the formula for area of a trapezoid a little bit easier. So I want you to add this, right? The area of the trapezoid can actually also, additional formula, can also be written as the height times the median. Why? Well, look what I circled in red. Well, that is by definition what the median is. So instead of writing this big, long, complicated thing, we can just simply write height times median. Now, you have to know what the median is, obviously. Okay, and you won't always know, but here is a second formula for area of a trapezoid. So the standard formula for area of a trapezoid is the one that you wrote, well, that you were supposed to write down. This one right here, that's your standard one. But we get this alternate one right down here that if you're given the median and the height, boy, it makes your life a whole lot easier. There's no divided by 2. There's no, I mean, it's just two numbers multiplied together. And that makes your life a whole lot easier. However, you must be given the height and the median. Am I confusing you?
Only minorly.
Okay. Well, we don't teach you this in 7th and 8th grade, right? Because we don't talk about medians at that point. But yeah, it actually makes your life a little bit easier. And then to me, when I first learned this, it was kind of, oh, my word, that why didn't you tell me this makes my life a whole lot easier? So watch this one. So it says, what's the median of a trapezoid? What is the median of a trapezoid whose area is 300 and whose height is 10? Okay. If we take that formula that we were just given now, that the area is equal to the height times the median, and we simply plug in what we're given here, we're given that the area, that would be this part right here, is 300, and the height is 10, we can figure this out pretty easy. It's just a quick substitution, right? We substitute those numbers in, and to solve this, we would simply, Matt,
Do something.
well, what would that something be?
You've actually lost me now.
Well, do you see where I put the 300? I put it for area of a trapezoid because it literally says that the area is 300. So all I'm doing is taking this and substituting in a 300. It says whose height is 10 inches. So I'm taking this and substituting in 10. Now there's only one variable left, and that variable is m for median. Now just simply solve for it. So guess what the median is?
I'm just letting you know, I can literally only hear your voice. My screen is completely frozen. I have no idea what's happening.
I have an equation that says 300 is equal to 10 times m. And I was just simply asking you to solve for m.
Okay, so wouldn't you just divide both sides by 10?
Yes. Therefore, the median's 30 inches. And that is pretty darn simple. Now, you couldn't have done that unless you knew this formula, obviously. Well, now you do know that formula. We better do a different one. Can you see the screen now?
Yes, I can. It's working again.
Okay. So it says, what is the height and median? So I'm solving for two things. This is answer number 1. This is answer number 2. Of a trapezoid whose bases are 27 inches and 9 inches and whose area is 90. So this one's a bit more complicated. We'll just take it piece by piece. So I don't know, maybe we start off with our normal trapezoid formula and plug in what we got. We're given what? 3 pieces of information here. We're given the area. The area is 90. So I can replace this with 90. We're given the 2 bases, 27 and 9. So I could replace that with 27 and 9. And what I would be missing is the height. Well, that's good. I can solve for that. So all I'm going to do is plug in those numbers. Matt, do you see what I just did?
Yes.
Okay. Well, we can solve that one. That one's pretty easy. 27 and 9.
You can solve it if you can do algebra.
So 27 and 9 is 36. 36 divided by 2 is 18.
Yeah, I almost said 16 a second ago. Oh, okay.
And it turns out that 90 is divisible by 18. The height's 5. Cool. We just answered question number 1. The height is 5. Question number 2, though, says, what is the median? So for that part, we're going to have to refer back to that second formula for trapezoids. And that second formula has the median in it, right? It says that the area of the trapezoid is equal to the height times the median. Well, notice once again, I know that the area of my trapezoid is 90. I just figured out the height was 5. Now I can plug those numbers in and solve for the median. Does that logic make sense?
If I could see the screen, yeah.
All right. I have no idea. You're clipping out as well, too. I don't know if your internet's going in or out or not, or maybe it's mine. I don't know.
I have really bad internet. I live in the middle of nowhere, so it's probably me.
Okay. So we plug in those numbers, and then once again, notice we're only missing one variable, so we can solve pretty easy. Divide both sides by 5, and we get the median is 18. So tonight for homework, they may give you a series of information involving a trapezoid. You're going to have to remember that you might have to use both formulas to answer one question. And it's your standard trick in algebra. The standard trick in algebra is to use the formula that when you plug in the given information, you're only left, notice I'm only left on this one with one variable. I'm only left with this one with one variable. And when you only have one variable, well, then it's very easy to solve for, okay? All right, but notice if I had chosen, for this particular question, if I had chosen to use this second formula first, right? The second formula, remember the second formula says this right here, height times median. I don't know either one of those information at the very start. All I know that the area is 90. So if I had written the second formula right from the very start, I would have gotten that 90 is equal to, well, I don't know what the h is, and I don't know what the m is. Now I got a formula with two variables. I can't solve for that, okay? Lastly, I did want to point out that median is defined as the two bases added together divided by 2. So from the very start, since you are given the two bases, you could have from the very start used that particular formula to find out what the median is. You didn't have to, though. All right. All right, Matt, what I need you to do, though, is open up your book, and then we're going to look at some of the classroom exercises. We're going to look at the table and the classroom exercises just to make sure that we can do some of these, because I know the table usually kicks people's butts. So I'm sorry, I said the classroom exercises. We're going to look at the written exercises. So on page 4,
I never get.
So on page 436.
I never get through the table.
Well, that's why we're going to do a couple in class here so that you don't run into a problem.
I got to that page quick this time.
Cool.
Good.
All right. So pick one, 1 through 8. Pick one and we'll do one.
Let's do 7.
All right. Number 7. Assuming that as the numbers go up, they get harder. Let's see if that's true. So we'll do number 7. Now, we are dealing with a trapezoid, so sometimes it helps off the side, just draw a generic trapezoid, and then we'll fill in the information. So we're told that base 1, we're going to assume that base 1 is the larger of the two sides. Base 1 is 7. We don't know base 2, so we'll put an X there. Or actually, let's just put a literally base 2. So base 2. We are also told that the height is 9 root 2. 9 root 2. And we're told that the area, A for area, that the area is equal to 36 root 2. 36 root 2. We don't know what the median is. So M question mark. All right. So obviously there are two question marks we got to figure out. We got to figure out what is base 2, and we got to figure out the median. So let's just handle it one at a time. You have two, I'll do it in blue. You have two basic formulas. Area of a trapezoid is equal to the height times base 1 plus base 2 all over 2. And the second formula, area is equal to height times the median. So I'm gonna, I wrote this in blue to figure out which formula to use. This is kind of something you'd probably do in your head. I'm gonna go to each formula and see if we have one or two different variables. All right, so let's see. I know the height. I know base 1. Therefore, the only thing I'm missing is base 2. I could use that formula. Oh, and I know the area too, sorry. On the second formula, well, I know the area. I know the height. Hey, I can use either formula. Look at that. There's only one missing letter. It's in blue for each formula. So it doesn't matter which one I use. I actually have to use both, right, to find the answer. So let's do that. Here we go. Which one do you want to do first, Matt? The easy one or the more challenging one?
Harder first.
All right, so that's the one on the left here. So I'm just going to type in everything I know. I know the area is 36 root 2. That's part of the given information. I know the height is 9 root 2. I know that base 1 is 7. What I don't know is base 2. Okay, and this is all over 2. Now you could use the distributive property first. I'm going to choose to get rid of the 2 first. Matt, how do we get rid of this 2 on the bottom?
I would say just multiply both sides by 2.
You got it. So we're going to multiply both sides by 2. So that gives us 72 root 2 is equal to 9 root 2 times 7 plus base sub 2. Okay?
That is way too many 2's.
That's way too many 2's. You got two options. You can either distribute or you can divide out this 9 root 2 right from the very start. Which one you want?
Divide out the 9 root 2. So that sounds easy.
It is easier. So we're going to divide both sides by 9 root 2. If you use the distributive property, it just makes a bit of a mess. It'll still work, bit of a mess. So notice the 9 root 2's cancel. Oh, that made our life a whole lot easier. The square root of 2's cancel. Oh, our life is really easy. And 72 divided by 9 is 8. Oh, look at that. Is equal to 7 plus base sub. Look how just a little bit of knowledge of algebra makes our life a whole lot easier. Therefore, how big is base sub 2? Or base 2?
That's the hard part.
Well, just get rid of the 7.
Would you just subtract 7
Yes.
from both sides? So it would be 1.
So first answer, base sub 2 is equal to 1. We're halfway there. Okay. Second one is equally as easy. I'm going to put a box around this. I'm going to use this formula here. So area we already know was 36 root 2. So 36 root 2 is equal to the height, which the height was 9 root 2 times m. Same trick as the previous one. What are we going to do first?
Just divide by
9 root 2.
9.2. 9 root 2, sorry.
And notice the magic here. That whole thing cancels. Square root of 2 cancels. And 36 divided by 9?
3.
What?
No, what is 36 divided by 9? I can't do math in my head. I'm sorry. It's 4.
There you go. So there is the answer to question number 7. Both answers. And
I used to be
pretty
able to
much-
do all sorts of math in my head, and now I can't.
Yeah.
Sad.
As I look at it, the only ugly one, maybe number 3, because there's fractions involved. Change those fractions not to decimals, because some of them are repeating. Two of them are repeating. Change them to improper fractions and just use that to multiply. Number 8 is slightly challenging as well too. Okay, so there's how the table is done. Now pick any one of the 10 through 21. Pick anything you see that you think might be challenging.
We do 13.
Sure, 13 looks like it's a special right triangle one. That's a good one. All right, so 13, it's a trapezoid. Is it isosceles? It is isosceles. It's an isosceles trapezoid. The legs are 3. That's a horrible isosceles trapezoid. This angle right here is 60 degrees, so it's isosceles, so is this one, 60. Therefore, we get a special right triangle.